In this orbital representation of an Sn2 mechanism, the focus is on electron flow and the orbital changes which occur during the course of the reaction. It will better illustrate the concepts of backside attack and inversion at carbon. The top panel shows one unshared pair of electrons of the oxygen anion and hydroxide. This pair is in an sp3 orbital. Electron flow begins with this pair. In the electrophilic methyl chloride, the focus is on the bond which will break, the molecular orbital between carbon and chlorine. Each of these atoms is also sp3 hybridized. Bond formation results from the overlap of orbitals, and only 2 electrons are allowed per orbital. In an Sn2 reaction, bond making and bond breaking occur simultaneously. Therefore, as an electron pair moves in, another electron pair must move out. The new bond formation begins in the only available area, the empty back lobe of the bond that will break. The middle panel shows the transition state, where orbital overlap between oxygen and carbon is beginning, and orbital overlap between carbon and chlorine is diminishing. In the bottom panel, bond formation is complete, and oxygen and carbon share 2 electrons. The electron pair that once was shared between carbon and chlorine now belongs only to chloride. In motion, the hydroxide approaches carbon from the side opposite to the chlorine. Through this approach, the oxygen orbital with the unshared electrons can begin to overlap with the empty lobe of the bond it will replace, the carbon-chlorine bond. As this overlap between oxygen and carbon maximizes, the overlap between carbon and chlorine diminishes, with the electron pair going to chloride. The sp3 orbital of carbon inverts in the process, causing inversion at carbon.